Good afternoon, everybody. Thanks for joining. Looks like we're almost at what I would expect people to join, so we'll get started here. This is going to be the second to the last talk of the year, just as a reminder. Next week we'll have Persona giving office hours, but we wanted to end on a strong note, so we're going to be talking all about supercomputing since it's that time of year. So we have Brenna Meade, Tom Costello, and Zhan, and they are going to be talking a little bit about some of the work that they did last year at SC24 on IPv6 wireless networking, and then probably a little bit of a foreshadowing about what's going to go on this year as well. So I forget who's going to be starting us off, but it's probably Tom, so I will turn it over to Tom.
Thanks,
All
Jason.
right.
I'll turn it over to Brenna.
Ah, there we go.
Hi, everyone. As mentioned, my name is Brenna Meade. I was the SC24 SCinet Technical Director. I'm also a Senior Network Architect at Indiana University. And I'm also the Program Director for Workforce and Networking at Supercomputing WINS. So I wear a lot of hats, but today I'll be talking mostly about SC24 last year and the prep we're doing for SC25 this year, along with Tom and Zhan. So we're going to be talking about seamless IPv6-only transition on SCinet's SC24 v6 wireless network. Next slide, Tom. So today we're going to do a little mini overview of SCinet for anyone on the call who doesn't know what that is. I think many people do, but just in case. IPv6 at SC24, so last year. Then Tom and Zhan are going to go deep into the technical specifics about what we did last year, the results we got, and where that leads into the future. And then we'll talk a little bit about 2025 and beyond. Next. So we'll start with what is SCinet. SCinet is two distinct but interconnected networks built by volunteers to support the Supercomputing Conference. If you haven't been to the Supercomputing Conference, I highly recommend you attend. It's a pretty incredible feat. Those two distinct networks are a production network, which is all the wired and wireless internet access for attendees and exhibitors, as well as live streaming of the sessions and the workshops at the conference. But the most fun and I think the most interesting part of SCinet and what SCinet supports is the research network, or Science DMZ. This network supports the Network Research Exhibition, NRE, and also SCinet's experimental network projects, XNet. So as we'll go into this, the IPv6 network was generally on the production side. But if you have any questions about the research side, do let us know. We'd be happy to answer those questions as well. Next slide. Just to kind of give a quick overview of some of the numbers from last year, we delivered 8.41 terabits per second to the Georgia World Conference Center in Atlanta, 18 400 gig connections, 33 kilowatts power draw, 200 SCinet volunteers from 9 countries, 34 states, and 114 institutions, $47 million in donated or loaned equipment, software, and services from 36 contributors, almost 40 miles of floor fiber deployed, 116 miles total, over 2,500 fiber patches in total, and over 450 wireless access points deployed. Next slide. These are the teams that make all of this happen. As you'll note, there are technical teams and there are non-technical teams such as communications, contributor relations, logistics. Each and every team is equally important to the success of SCinet and to the success of those two different networks and to the success of our support of the Supercomputing Conference in general. So if you have anyone on your team at home, at your home institution, that would be interested in any of these teams, please let us know. Please reach out to us, and we'd be happy to talk to you further about these teams or getting on these teams or participating in SCinet. So please let us know. Next slide. This is the architecture diagram from last year. What we like to point out, I think, in this architecture diagram is the interoperability that we do between many vendors. As you can see, we've got Juniper, we've got Nokia, Arista, Aruba, HP, And all of these different contributors, all of these different pieces of hardware are all used within this network to support both those two initiatives, the production network and the research network. We find that there's very rarely an interoperability test on this scale that can be spoken about in a way that we speak about SCinet. So these contributors work together to reach the ultimate goal, which is, again, supporting the conference and supporting our researchers through the supercomputing conference. So if you're interested in a larger version of this diagram, or if you have any questions about the diagram itself, feel free to ask those in the chat later. Next slide. So now we're into the nitty-gritty. Over the past several years, so since SC22, there's been a pretty significant push within SCinet and also within the communities that volunteer at SCinet, so DOE, federal employees, people at research and education institutions, to increase the implementation of IPv6, increase training of our employees and our volunteers on IPv6, and also just get the word IPv6 to become sort of less of a dirty word or less of a word that scares people. Tom is laughing, which I think is evident of where we're still at. So at SC24, we had a few IPv6 goals. A few of these goals were carryovers from previous supercomputing conferences, previous initiatives from previous technical directors. But as I said, we continue to push IPv6 training and implementation within the SCinet group, again, to make it less scary. So we had several wireless SSIDs, but specifically we had SC24 V6, which is IPv6 only. We had some incentives for conference users to connect to that SSID, such as prizes, stickers, lanyards, things to sort of drive them to test the network out, give us some data. We also had Eduroam and SC24 dual stack. Both of them, as I mentioned, were dual stack, not IPv6 only. But the ultimate goal is to eventually sort of head in that direction. We also had management network v6 only, where we could. Those places that we couldn't, we asked our teams, that great list of teams that we mentioned earlier, to document and work with vendors about why we couldn't implement IPv6 only on that management network, and ask questions about the future of their hardware in terms of IPv6 support, so that we could send that information out to the community, to those that are thinking about implementing v6 only, and become a resource for our users and for the folks that are working within SCinet. We also had v6 only peerings from SOCS, Aurelion, Internet 2, and ESNet. Next slide. So we just wanted to give you sort of a visual of the signage that we had at SC24. As you can see, we were really trying to get people to try the IPv6 network, again, with those incentives and just the signage saying, please try us. If you have problems, please come to the help desk and tell us what you experienced. Please give us data about what you experienced and what we can do in the future to make this a more seamless experience for you on public Wi-Fi. So I just wanted to give you all kind of a visual of what we did in terms of our v6 network advertisement. Next slide. As I mentioned, SC24 and Eduroam were dual stack. We configured the SC24 V6 SSID based on lessons learned from SC23, which I think Tom will go into a little bit more later. If you want to read a little bit more in depth, we do have the SC24 Indus paper that discusses NAT64 and DHCP option 108. If you haven't read this paper, it's actually really interesting. And thank you, Tom, for all the work that you did submitting that paper and working on it. This year, in the past, we had done NAT64 on Palo Alto boxes. That created some limitations, some challenges in SC23. So we chose to do NAT64 directly on the Juniper SRX 4300. And we also did something different this year with our redirect to test IPv6.24.seconf.org. And I'll go into this a little bit more, but this redirect allowed users, successful users, to know immediately that they were successful, that they got an IPv6 address, that they were traversing the internet in a way that was expected. It let less successful users know that they needed to visit the help desk. Again, we weren't necessarily looking for everyone to be successful in connecting to this network. We were looking for additional data, things we could troubleshoot, things we could tell the community that we experienced. We also implemented several more DNS64 servers in our architecture this year. It would be interesting if anyone's interested to look at the SC23 architecture, which we do have, and the architecture for SC24. You'll note several more DNS64 servers and sort of a difference in how we implemented IPv6. Next slide. So what happens when IPv6 doesn't work or it's disabled? So we just wanted to give you sort of an example of what you would see on the show floor if IPv6 didn't work. So you would get this page that showed 0 out of 10, no IPv6 address detected. The reason we did this is because in SC23, we had a lot of users that would connect to the v6 network and think it was working, and it wasn't. Or people who would connect to the network, not get out on the internet, not have internet access, and then just quit and move back to eduroam or the general open SSID. And the goal of this forwarding that we created, this sort of capture page, was to get people to go to the help desk, again, to get them to give us the data that we wanted, to help us troubleshoot with them so that we could, again, give data to the community, have more troubleshooting skills, and kind of see what was going on in our network on devices that weren't working. Because, as many of us are engineers, it works for me. Why doesn't it work for you? And so the hardest thing to do with users is always to get them to tell you it doesn't work and get them to ask for help. So this was trying to push people to the help desk and to ask for help. And it actually worked pretty well. So next slide. What did we experience at SC24? We found that SC24 v6 was much more reliable than SC23. Some of the issues we saw were with v4-only VPN configurations, causing split tunnel problems. This was a known issue, but we did see it again. We also saw Windows 11 users with issues with Slack. We did not see this issue as much with macOS. But again, that was just another piece of data that helped us determine our next steps and helped us learn how to troubleshoot. One of the big issues we also saw was that with eduroam, the goal is seamless connection, right? So if you go from University A to University B, your laptop will just connect. Well, our attendees had the same experience at supercomputing, which is very exciting. That's what we want. We want eduroam to work for our users. But sort of the flip side of that is that users automatically connected to eduroam and they never tried another SSID. They didn't even know that they should. So again, that's some of the reasons that we created those incentives and that we had all that signage, was to try to get people to look at their SSIDs and try something else or experiment a little with what they were doing. So this is some of the data that we got from SC24. Some of these issues, as I mentioned, we knew existed, but I think that Windows 11 issue was relatively new last year, and again helped us with contributing to the community in terms of how this effort is proceeding. Next slide. Some interesting slides or stats from this year at SC20 or last year at SC24. We had over 2,400 max concurrent users, over 6,000 unique users, and over 150,000 IPv6 sessions on the firewall. Supercomputing is a conference attended by about 18,000 people. So our hope is that over time we'll get more users on our v6 only network. However, these numbers were an increase from SC23 and again from SC22. So we found some success in some of those incentives we created and the signage and things that we did. And I think overall, and Tom can agree or disagree, that we were pretty excited about the stats and the amount of usage that we got on our v6 network this year. So overall, we found generally we had a positive experience with v6. Next slide. So what's next? And Tom's going to go into this a lot more. But the things that we're thinking about next in terms of SCinet specific IPv6 implementation is multi-vendor NAT64. So as I mentioned, our NAT64 implementation has been on Palo, Juniper. We're looking at multi-vendor NAT64 in the same architecture. So not year to year, but in the same architecture. Continued education and workforce development in the area of IPv6. Continued research in VPN deployments. As I mentioned, we saw a lot of issues with VPNs, specifically from folks that worked at federal agencies and/or federal labs. Changes in infrastructure and configuration to support updated operating systems that support RFC 8925. Tom's going to go into that a little bit more as well. IPv6 only without DNS intervention. So again, without any of this sort of trickery that we did to supply that configuration page and that status page, and also a desire to better understand and implement RFC 772RA suggestions. But I think the biggest takeaway from SC24 that I think Tom and Zhan was our biggest accomplishment in SC24 was that it was stable enough to use in production. In SC23, we found that it was not stable enough often for users to stay on that SSID and to continue to use it. At SC24, we found that users, once they were connected, stayed on it, used it, and generally didn't see a lot of performance issues other than the ones that we already mentioned. So as I was talking to the technical director for SC25, Corey Eichelberger from TAC, I said to him, "What are we doing with IPv6 this year, Corey?" And he said to me, "Brenna, it's production now. We're just going to keep doing it and we're going to keep making it better." So it's no longer some sort of experiment. It's something we're using each and every day in production. And I think that was our ultimate goal. And I think Tom will go more into what we hope to do next and what we're seeing in the community in terms of what's going to happen into 2025 and 2026. So next slide. And then this is just a plug from Brenna. If you have not attended SC25 or have not attended supercomputing itself, SC25 is in St. Louis. It's going to be a great time. If you are interested in volunteering for SCinet next year, please let us know, and we'd be happy to connect you with folks that will make that happen. And I think this is where I pass it over to Tom.
Thanks, Brenna. And I will pass it back over to Zhan for, I believe you'll get the next couple slides and I'll take it from there.
Yes. So I will talk about the test IPv6.scconf, which is our mirror of the test IPv6.com. Some of you might have seen it. It's a very nice open source website made by Jason Fassler that whose GitHub link is down there. It runs a suite of tests for general internet connectivity and also for IPv6 readiness. So the idea of having a mirror of this site was starting at SC23, so that as we started to introduce the experimental v6 only wireless network to our attendees, we would have an easy way for our helpdesk personnel to identify issues. So when you visit this site while on the side of conference, this will run some JavaScript-based tests against our mirror server, which has known good configurations of v4 only dual stack and v6 only DNS records. along with some simple feature tests like large packet supports and whether the client is preferring v6 when it's presented with a dual stack setup. Oh, sorry. So having this locally hosted on the show floor, to well, first of all, let us do the branding for SC on this side, which is nice to keep the whole conference experience immersive. But also, as we operate all the wireless endpoints on the show floor, we can tailor our messages on this side so that when users go to the site, they will see relevant messages pointing them to help desk if they have any issues. So in SC23, as Brenna mentioned previously, we had some clients who did not have working v6 setups connecting to the SC23 network and experienced broken internet, which at the time, the site wasn't customized to tell them whether it is actually an issue with their client device or that our Wi-Fi setup is actually broken. So this is something that we wanted to improve at 24. So thanks to Tom's work in the months after 23, he had the idea to do DNS intervention between the client and the endpoint, so that we have kind of a in-flight Wi-Fi experience for a client that only supports v4 when they connect to the v6-only Wi-Fi. And next slide, please. Yes.
Oh, I'm sorry. There we go.
Yes. Yeah. So so in SC24, instead of just having signs telling users to go to the site to test out their connectivity, when people connect to the SC24 v6 endpoint, if they have only v4 connectivity, we will actually direct them to this test site, run a test to tell them that your IPv6 is not working. But when we were doing the initial setup, we noticed the issue where the existing setup of tests would give a erroneous result because the test IPv6 code actually calls back to the externally hosted test IPv6 instances, and some of them are available on dual stack. So they would actually call back to the user's device and say, you have internet connectivity, when in fact they do not. So the solution we implemented at 24 was we had extra pair of DNS servers that we call poisoned, because when we had set up on these DNS servers where if the users give query for any v4a records, they would instead get this site, and that includes the external test IPv6 test URLs, so that when the script tests for this connectivity, it actually fails properly, and they get a 0 out of 10 score. So on the right, you can see the top screenshot is the before screenshot, where it will say there's no IPv6 address, and yet it still gives you a 10 out of 10 score. And the picture below tells you that you do not actually have IPv6 activity, and you should come to our help desk, and we may help you. Next slide, please. So this is an overview of the DNS servers that were set up on the show floor last year. So we have a pair of general purpose dual stack server DNS servers that serves all of the networks. We have a pair of IPv6 servers that's serving the v6 only network, and also one a client device with RFC 1825 enabled says they prefer a v6 resolver, and they will be pointing to that instead. A third pair of Poison DNS servers are set up to redirect all v4 requests and pass through the v6 request to the primary servers. So on the right, this is a snippet of what the setup looks like on the DNS server. Notably, Slack is on there because Slack is v4 only and remains so as of this date. Our main conference site, unfortunately, is also on here because we noticed on AOS without proper RFC 1825 support, occasionally it will get redirected back to our test IPv6 client test website, which is not desirable for a good conference experience. So the decision we made last year was to pass the releases in that until our main site becomes dual stack as well. And you can see down there was some additional redirects, additional NX responses for the external test IPv6 test instances mentioned before. Next slide, please. So for 25 and beyond, first thing is whenever Windows 11 actually gets proper 1825 support, we will need to re-verify our setup and make sure it's working properly issued. And notably, Network Manager on Linux added support for 1825 earlier this year, so this leaves Windows 11 pretty much the last major OS that still does not have proper support. Further, we want to improve on the front of metrics. The existing solution for metrics collection on the test IPv6 code base is a very old and bare bones solution that pretty much just collected traffic metrics. So we want so beyond just client counts, we want to further collect and aggregate test results to see the distribution of v4 only versus dual stack v4 versus v6 only clients that we're receiving, and as I previously mentioned, preference for v6 when they're dual stack. All of these would be very valuable metrics to present at a conference to show the current state of adoption. The other point of improvement that we noticed from last year was distinction between dual stack and v6 only clients. Last year on the conference floor, because we have a net64 setup, when clients come from dual stack or v6 only, they will show the server will see them as exactly the same. So it was difficult to tell them apart. So this would be something that we want to try to figure out this year. Lastly, testipv6.com is experiencing a somewhat major change as Jason Fessler has announced his intent to retire the service sometime earlier. So it looks like he has since find a regional registry to take over the hosting, but it's it's still questionable whether the code base is going to be continued maintained. So IP6.biz is a alternative site that we have found and may try out as we do the setup for SC25. It offers some subset of tests that test IPv6 was doing, with a bonus point that it's, I believe it's a entirely local hosted solution. So we shouldn't have issues about it calling back to other public endpoints. And I think that is my last slide. So I hand over to Tom.
Right. Great, thank you so much. So I think that test-ipv6.com news is probably a great segue into some of the other struggles that we're having with IPv6 only living here in 2025. I think all of us have brought this up at least once now, that Windows 11 is still struggling when it comes to that RFC 8925, better known as IPv6 mostly, or option 108 support. So we were hoping to have maybe like a couple people in a private preview of that for SC24. That didn't happen. I believe that is available today, and we'll hopefully have some of those people connect to SC25 v6. But every indication is that update is not going to make it into, I want to say it's like that 25H2 update that Microsoft pushes out for general availability, which is really too bad, because if we had that, that would certainly sway the SC25 v6 numbers much, much better with having all of the Windows clients, but we're not quite there yet. Again, GitHub and Slack still IPv4 only. In fact, that screenshot a couple slides ago of the DNS mask config, and I think probably half of that was like some of the Slack URLs. And if Slack was v6 dual stack, we wouldn't have had to go through that exercise or have to do any of that. The one good thing about that, though, is every client that connected to SC24 v6 that sent a Slack message, all of that traffic was working through Net64, and the end user didn't really know any better. So pretty cool we can say that, but would have been much cooler if it could have been IPv6 the whole way through. Obviously, GitHub and Slack are heavily used throughout the HPC community, so that can sometimes make deployment a bit trickier. If you are receiving any federal funding, the federal IPv6 interagency meetings at GSA used to be a great resource for all types of different kind of case studies and updates about what everyone else is doing. They've been on hiatus for a while now. Maybe we'll see someone pick that back up, but for now, that momentum has at least paused. The OMB federal mandate as well, all of the deadlines for that, the last one about a week and a half ago for the end of FY25 has come and gone. So we don't necessarily have that sense of urgency anymore of we're trying to get all of this IPv6 only or IPv6 mostly done for those deadlines with the mandate, but the mandate's still there. And even at SCinet, SC25 has been super interesting because with that record-shattering attendance of SC24, things like the IPv6 birds of a feather, which has been happening since SC22, didn't quite make the cut. Again, everything's in high demand for SC25. Excellent problems to have, but we'll really need to show up with our A game for many of the IPv6 things that we're doing going forward to get into that already highly selective technical program. As mentioned earlier, we had a paper in the Indus workshop, which is hosted by SCinet. It was awesome to see technical academic papers about IPv6 at that workshop. Didn't quite make the cut this year, but I must say we had some absolutely wonderful feedback as to why that is. And I'm getting really excited for next year, having heard some of the super exciting things that people are doing with IPv6 and UEFI to provision HPC infrastructure across the globe. So many topics like that might be better fits next year. But definitely still a lot of good momentum going into next year, but certainly things this year have not always worked out sunshine and rainbows for IPv6. Now, next year, I'm again very confident that fingers crossed we will finally see Windows 11 get the RFC 8925 support. And even better yet, we're hoping to see it enabled by default, just like all the Apple and Google operating systems have been doing for years now. As mentioned earlier, Network Manager and Systemd do support RFC 8925. That's great. But I've also heard that you need to either manually install CLAT-D or something similar to get the client-side translator aspect of things going. So it's not quite working out of the box. I hope to be wrong on that. Maybe there is a distro that's figured that out. If so, please let me know. But I think we'll hopefully see that become smoother as time goes on. The IETF has been very busy with all types of new standards and drafts, advocating both for the IPv6 mostly things that we've been promoting at SCinet. I think one I wanted to call out is that 6 MOPS document. Some of the lessons learned in that document are because of the struggles we had at SC23. So seeing that information go from SCinet to a standards draft that the whole internet can use at large, it's pretty great to see. Speaking of standards, RFC 8781. So this is the Pref64 standard so that in a router advertisement, you can advertise out the Net64 prefix without needing to go through DNS or other things to get that. And it's a newer RFC. There's not many vendors that have that baked into their network operating systems today, but we're seeing that number grow. And every time I see a router or firewall vendor, I always make sure to ask them about how that support's coming along. That enables us to do some cooler things with CLAT that we'll talk about a couple slides from now. Hyperscalers. So a couple of years ago, or more like 5 years ago, it felt like there was a time where you would actually not want to do V6 because of what's happening in Google, AWS, Azure, et cetera. But it's really changed these past couple of years. We've seen AWS has made major efforts to make more of their services kind of first-class citizen for IPv6, just the way that IPv4 functionality has always been, to the point where you can do V6 only in AWS. And of course, AWS and I believe the other hyperscalers do this as well, where there's now a fee charge per IPv4 address, further incentivizing the move towards IPv6. Multiple SC25 NREs this year are going V6 only. I know there's one that involves perf sonar quite heavily. Perf sonar works great for V6 only. The other being with site tags, and site tags requires functionality that is not present in IPv4. So some good trends there. We're hoping to see more IPv6 in all 3 legs of the SCinet research triangle off to the right. I don't know if that's what that's actually called or not. There's probably a better name for it. But regardless of everything happening with the delays in Windows 11 and some of the other things that we've seen, still very optimistic about the work that we've done, both as SCinetters and at our homes and institutions regarding V6 adoption. Things are continuing to get better and better every day. So one of the things that happened at SC23 was we started talking about originally having the SC23 network be strictly V6 only for SC23 V6. So no IPv4 whatsoever, no option 108. And then on the XNet team, in particular, Nick Baraglio and Jeremy Duncan, they really were telling me loudly, like, no, we have to do option 108. And at first I didn't understand why. Like, I've been doing IPv6 only at my home institution for over a year, telling my upper management that we need DNS64, and now you're saying we don't need that? I was pretty thrown off. And so they took the time to explain to me why that is. And eventually I saw the light that, yes, this whole client-side translator thing that we've been doing with our RFC 8925 is indeed the optimal solution. And talking with some coworkers and other people that, again, we had told our management that we need DNS64 and, well, maybe we don't with CLAT now. And I started giving this analogy of a third brake light that seemed to be pretty well received. So I figured I'd take a couple minutes to kind of go through that here. And that's this picture here is of a 3rd generation Pontiac Firebird or Chevy Camaro in the mid 80s. So 40 years ago, there was no third brake light requirement, so there is no third brake light on this vehicle. This is kind of what we've had with IPv4 only. Again, it's simple. There's only one protocol, but of course, not quite with the times, right? If I go to this next image from 1986, again, that third brake light mandate came out, and it looks like someone just went down to an auto parts store and kind of bolted on that light. Kind of clunky looking, it's very out of place. And that's kind of how we were with V6 for a while, where the operational burden of dual stack, having to support two versions of Internet Protocol instead of just one. Or if you're trying to go V6 only, having to deal with all the clunkiness of DNS64. And there's some issues with DNSSEC and other related things. It was not the prettiest. It got the job done. And ultimately, in the case of this picture, you have that safety improvement of the third brake light. For the case of V6, you have all the great stuff that goes along with not having to deal with address starvation or Net44. But again, a little bit clunky. And what we're really trying to get towards is this picture of the last year that they made the third generation Trans Am, or in this case, a Firehawk. So the third brake light is integrated with the design. It looks cool. And this is where we're at with CLAT. So with CLAT, you don't need DNS64. Again, that's where that Prep64 and the RA gets so interesting, because you can, without any IPv4 dependencies, tell a client that supports it with the CLAT, hey, this is the translation prefix to use if there's anything still stuck in V4 land, and still have that IPv6 address and all the benefits that go with it, and everyone's happy. So this is what we're going for at SC24 V6. And I feel like very much how nowadays it's kind of a rarity to see a car without a third brake light on the road. Ultimately, that's where we'll be with IPv4 someday. We're not quite there yet, but we're making some good progress, and hopefully we're getting some good lessons learned out there as a result of this work. So I'll wrap it up by just including that the only thing that would make this picture better is if we threw the SC24 logo that just so happens to look pretty similar into the cards. And again, cannot thank everyone at ESNet Epoch for having us today. And there's just far too many people to thank over the years making these V6 initiatives work for SCinet. Happy to take any questions at this time.
All right, well, thank you, all three of you, for going through that information. All right, everybody should be able to unmute yourselves if you want to ask a question directly, or raise your hand, or use the chat room. I guess I can ask a warm-up question here. What was the biggest thing that you learned from your 2 years of experience doing this in a different environment than your home institution? You know, you of course do it at Argonne and are working under a different set of requirements than an open conference like SC. But what was something that you learned that you weren't expecting?
I like that a lot. So the first thing that comes to mind is the way that at SC23, there was one particular institution that will remain nameless, where they had these host-based firewalls on their workstations that were effectively blocking the ether type of IPv6. And so we get these clients that were just stuck in the super ugly state where the RFC 8925 was telling them, hey, you support CLAT, go ahead and disable IPv4. But their IPv6 stack was broken. That was not something that I had ever experienced at my home institution. I had never really thought about that prior to seeing that firsthand. And that was a really good lesson learned. That's probably the biggest thing that made it into that IETF draft. I think by far that was probably my biggest takeaway. And some of the things in regards to Slack and the way that, again, it being V4 only, and some of those corner cases that we didn't quite see in our test bed leading up to SC24. But once you have a very large number of workstations from all over the world on that floor, it becomes very obvious where the cards lie. I'll be quiet and see if Brenna or Zhan have any further comments there. Again, all the work that went into fixing that mirror, it took a while, but I think ultimately we were pleasantly surprised with how little people were getting stuck in that captive portal jail.
I would add, I think the biggest surprise for me was the human element. Getting people interested in the topic, getting people to use it, getting people to see why we were trying to push this so hard. There was a lot of pushback from even our own engineers saying, why are we doing this? The other ways work just fine. We don't need to do this. We have plenty of IP address space. And so for me, the human element was the most surprising. I think technically we overcame the challenges relatively well and relatively simply. not simply, but efficiently and effectively, but just really getting people to buy into what we were trying to do and understand why it mattered to the community and to the engineers that were working on the project. I think that was my biggest surprise.
Okay. Reminder, if anybody does have a question, you can use your hand feature or just unmute yourself or type it into the chat room. There was just one chat comment in there about how testipv6.com will still stay up in some form, but you guys have acknowledged that already.
I got one interesting comment in the chat from Clark Gaylord from GW that actually dropped off that said, it's interesting because SCinet had been doing dual stack for many years, especially in the 2015 to 2016 range. What made you all decide to sort of focus your efforts more on IPv6 mostly, single stack configuration? And another comment about how it's generally good for the community. And I think the answer to that question is we got a lot of interest from folks from ESNet, folks internally within SCinet that were saying, hey, I'm doing this at my day job. Can we push this workforce development, this education within the SCinet community to educate engineers that are working on SCinet about this so that they can take it home to their home institutions? And again, that data piece that I talked a lot about earlier. But I thought that was an interesting question about how we've always done dual stack, what pushed us towards IPv6 only.
Good commentary. All right, last call for questions if anybody has them.
So yeah, a comment actually. You've inspired me to push some of my colleagues to try this at a conference we might be providing EduRoam for. So, would we? And the first thing I think I'll push for is making sure we've got IPv6. But would we be being rather too brave if we did that with was it option 108 that because I think essentially everybody that goes to the conference I'm thinking of is going to have EduRoam to a first approximation. So is that pushing things just a little bit too far at the moment with because I think there'll be some Windows clients, I suspect.
That is a fantastic question. And I know that there's at least one person, I should really remember the name of the institution, but they're in the UK, I believe, in London, and they have been doing option 108 on their EduRoam deployment. One of the things that in the past at SC, we decided against doing option 108 on EduRoam for two reasons. One being that, again, I think Brenna really hit the nail on the head on this, that we want EduRoam to be kind of no matter where you're at, it's the same user experience, whether you're in California or in Europe, anywhere in between, that it's as close to the same thing over and over again. So we want to be that kind of control group where it's dual stack, it's what everyone would expect. But I think that there is a very good reason to do option 108 on EduRoam, because when you think about it, the way that IPv6 is in abundance everywhere throughout the world, there really is no restriction on how many IPv6 addresses that an organization can get. But with V4, that's the exact opposite. Between having to fight through CGNet and everything else, I feel like kind of the cost benefit of potentially breaking a few people with option 108 versus not having to deal with CGNet. I feel like that's starting to really sway the pendulum towards doing all of this on EduRoam. And one thing that we mentioned in this paper is that there is an IETF RFC on EduRoam, or at least the EduRoam architecture. And again, I know that there are SCinetters that are very, very involved with the EduRoam architecture, and I'm sure it's changed over the years. But to my knowledge, there wasn't a whole lot of IPv6 in there. And this might actually be a really good time to change that. And one way or another, whether it's hey, everyone should be doing dual stack, or hey, everyone should be doing option 108 with Prep 64. I think we're at a really good time to be asking these questions. And I don't know if I have a 100% correct answer on that.
All right. I don't see any more questions in the chat room. So thank you everybody for joining this week. Like I said, this will be second to the last week. We're going to have Persona office hours, I believe, next week on the 17th. So that'll be the regular occurrence of that, where everybody can bring all their Persona questions. Oh, it looks like Andy did have a last comment there. Okay, even if a client has to go through NAT64 to reach an IPv4 site due to option 108 disabling IPv4, remember the native IPv4 is likely going to be going away through NAT, or going to be going through NAT anyway. Yeah, thanks, Andy. All right, well, thanks everybody. Have a good weekend, and we'll talk to some of you next week.